Let's go ahead and continue to move on here to example number 2. And now what we're going to do is that we want to write each rational expression in its lowest terms. All right. And so let's go ahead and start doing that. And the way that we want to actually approach these here is we want to be able to either cancel things out that are similar to both the numerator and the denominator, but we can't quite do that yet. Okay, so like we can't cross out that a and that a right there. Because the reason why that you can't do that is because it's connected by a plus or minus sign, meaning this entire thing is one group. It's all together. Okay, so we can't slash things out like that. The only way that you can do that is if it was like all multiplied by like a 3, and then like over here, like if this was like a 6, and now you can reduce that because it's multiplied now. But as of right now, there's nothing that we can simplify. So what we want to look at doing is, can we factor the numerator and can we factor the denominator? Okay, so let's just look at this numerator here first, and we're going to factor that. And I like to do my little karate X right here, and I multiply the first coefficient with the last term, so that's 6, and the negative 7 on the bottom. Two numbers that multiply and give us 6 and add to get 7. Oh, well, that's negative 6 and negative 1, right? Negative 6 times negative 1 is 6. Negative 6 plus negative 1 is negative 7. So what that does is this. This is why I do that. I'm going to rewrite this numerator. I'm going to rewrite it as 3a squared. See that right there? So there's 3a squared. I'm going to rewrite negative 7a as negative 6a minus a. Isn't negative 7a the same as negative 6a minus a? Yeah, it's the same thing, right? And I got this by using these two terms right here. This becomes my replacement of my middle term. And then I bring down my plus 2. So as you can see here, I haven't changed the numerator, just the way it looks. And so now what I want to do is I'm going to group the first two terms, and then I'm going to group the second two terms, just like that there, but this is not being multiplied. I'm going to put just a plus sign right there. It's plus this right here. And so now what we're going to do is that we're going to factor both of these terms right here. And let me just move this over a little bit to get some more room. So if I look at my first binomial, and if I factor that guy, 3a squared minus 6a, I can factor out a 3a. Because if I look at 3 and 6, they both have a 3 in common. And if I look at a squared and a, they both have an a. So now what goes back inside? Well, this is what you do. You say 3a times what is 3a squared? Oh, well, that's just a. And then 3a times what is negative 6a? Well, that's just going to be a negative 2. Okay, so if I distribute this back, I get my binomial right here. And then right here, plus, how do I factor negative a plus 2? Well, I don't want my first term to be negative. I want it to be positive, so I'm going to factor out a negative 1. So what goes back inside? Negative 1 times what is negative a? That's a. Negative 1 times what is 2? And that's a negative 2. Okay, and we have one last step here to factor this, right? Notice now we have a common factor of a minus 2, right? See how this is all one term, and this is one term. Each term has an a minus 2, so I'm going to pull out the a minus 2. If I factor out the a minus 2, well, what do I have left? I have the 3a left, and I have the minus 1. Okay? So what we've just done right now, we've done all this work to just replace the numerator. Okay, so the numerator now is a minus 2 times 3a minus 1. That's all we've done, is we just rewrote the numerator from expanded form to factor form. This is the exact same thing. They're equivalent, just they're written in different forms, okay? But now let's deal with the denominator now. Okay, this a squared minus plus 2a. I'm going to rewrite that down here. Plus 2a minus 8. All right, so we're going to factor this bad boy. Again, I always do my little karate triangle. Two numbers that multiply give us negative 8, and we add to get 2. Actually, that's a positive 4 and a negative 2. No, that would be the other way around. Negative 4. Nope, I had it right. this will be a positive 4 and a negative 2. 4 times negative 2 is negative 8. 4 plus negative 2 is a positive 2. Good, so now our denominator, so that means if I factor this now, it becomes a plus 4 and a minus 2. And once again, notice that I use these two to get those factors. Okay, so now I can replace the denominator now. Okay, let me just move this guy. I can move this guy right over here. So watch, let's go do that. So now my denominator was a plus 4 and a minus 2. Okay, is that what I got? Yeah. So now that we factor the numerator, we factor the denominator, now we go ahead and cancel any common terms out. And as you can see here, we have an a minus 2 on both the numerator and the denominator. And those we can cancel out because they're the exact same grouping. So our answer we have remaining on top is 3a minus 1. And in the denominator, we have an a plus 4. And that will be that one. Okay. All right, let's take a look at part B here. And actually, you know what? This is a lot of stuff going on here. So I'm just going to move this guy all the way down here so we're not getting all cluttered. Okay, so let's factor the numerator, and basically you just got to recognize that that is a sum of cubes. Okay, so let me write that formula down right here. If I have a cubed plus b cubed, then that is always going to be a plus b times a squared plus or minus. Let me think here. I think it's yeah, it's minus ab plus b squared. Okay, you know how we have sum of squares? Well, this is just a sum of cubes. So basically, if I rewrite my numerator, right, so I have t cubed plus 2 cubed. See that there? So this is kind of like our a term, and this right here would be our b term. This would be our b term. So basically, I'm just going to replace the a's with t and the b's with 2. Okay, so let me just do that down here. So I'll have t plus 2 times t squared minus 2t plus 2 squared, which is 4. Okay, all over t plus 2. And what do you know? Hata! Those are common terms that we can cancel, which then leaves us with our answer t squared minus 2t plus 4. Okay, cool. Let's go ahead and take a look at what we got over here now. Great, so what we have here is we have a number of terms on both the numerator and the denominator. And this looks like a factor by grouping. So I'm going to group together the first term on top, the first 2 terms, and then I'm going to factor, or at least group together the last 2 terms. I'm going to do the same thing in the denominator. So the reason we want to do that now is let's go ahead and factor each grouping. What is it? Let's factor out that greatest common factor. So looking at right here, see how they both have an m in common, an m and an m? So if I factor out that m, I have a minus b left, right? If I take out the m, I have a minus b, see? Plus, and notice right here, see how they both have an n? So if I take out the n, what do I have left inside the parentheses? Well, I have a minus b left. Okay. Let's just finish the numerator since we're doing that, and then we'll do the denominator. So now that we've done that, notice that now we have a common term of a minus b. See how they both have an a minus b? So let's go ahead and factor out an a minus b. So if I factor out a minus b, well, look what I have left. I have m and n left. I have m plus n left. Okay. And I want to stop right there because that's as far as I can go for the numerator. So I've just rewrote the numerator as a minus b times m plus n. Okay? And so now let's do the same process for the denominator. So I'm going to go and just bring this guy down then. Okay, so if we're going to factor this then, again, if I see right here that they both have an m in common, so I'm going to factor out the m, and I have a plus b left. If I look right here, they both have an n in common, so I'm going to factor out the n, and I have the a plus b left. And very similarly to what we just did in a previous example, see how they both have an a plus b in common, so I'm going to go ahead and factor out the a plus b. If I factor that out, then I have this left. I have m plus n left. Okay, so what I've done now is I've factored the numerator and got this up here. And now I've factored the denominator, and let me just write that down. A plus b times m plus n. And you know, our last step, we go ahead and go, wata. We could cross stuff out right there. Right, and then this is all that we have left. A minus b times a plus b. Cool beans.